St. Joseph's College, Irinjalakuda, in the Thrissur district of Kerala state, is an autonomous college for women affiliated to the University of Calicut and managed by the St. Joseph's Education Society of the Congregation of the Holy Family. This institution was established in 1964 as an answer to the ever-increasing demand for the higher education of young women from the middle and lower strata of society in the rural suburbs of Irinjalakuda. One of the first institutions in Kerala to be accredited in 2000, the college was accredited in the third cycle at A grade by NAC. In recognition of its efforts to empower women students with a transformative rather than additive purpose, the institution has been conferred the status of autonomy in March 2016 and the status of college with potential for excellence of the UGC in April 2016. The Department of Chemistry started functioning with the very inception of the college and has the history of 56 years. The department was upgraded to the level of a recognized research center of Calicut University in 2009. The department offers aided bachelor, master's and doctoral degrees in chemistry. Our department welcomes motivated students to pursue their degree. Remember, though this is a women's college, doctoral degree is open for any gender. A warm welcome to all participants to the international webinar series on chemistry for securing life, opportunities beyond your imaginations. This is more a experience sharing session intended to help chemistry students to shape their career. The Department of Chemistry is grateful to Dr. Subin Damodaran for his willingness to share his valuable time with us. Also, the department convey its gratitude to our beloved principal, Dr. Sister Asha, and to the IQAC cell, and also all the participants. Hope that you will enjoy this session. So with these brief words, I would like to invite Dr. Subin to handle the session. Dr. Subin, the stage is set for you.
So hello everybody. I hope everybody is doing fine. First of all, a very good afternoon everybody who are today listening this conversation or this webinar. Despite the fact that COVID is at its peak, let's concentrate on something else for an hour. So on behalf of St. Joseph's College, I welcome all of you to today's webinar session. Let's say a few words about the Organised College. So it's St. Joseph's College from Irinjalakuda in Thrissur. It's an autonomous college for women, and the affiliation is from Calicut University. And the management is St. Joseph's Education Society. The college was established in 1964 with a great mission, that is to empower the women students with a transformative rather than an additive purpose. So that's a great mission. And some accreditations and milestones of the college, as mentioned just below, it's not all. It was accredited in 2000 and it becomes an autonomous college in 2006. St. Joseph's got the potential for excellence from UGC in 2016, and it has approved as a research center of Calicut University in 2009. So if any of you are interested in reading more, you could always look back into the website of St. Joseph's College. Moving to the next slide, or to begin with, first I would like to express my sincere thanks to the organizers of this webinar, which is the chemistry department and its strong team, and also the principal, Dr. Sister Asha from St. Joseph's College, or from the well-known institution situated at the heart of Irinjalakuda town in Thrissur district. So once again, thank you very much for the invitation. With this webinar, we were not intended to place you somewhere immediately. So it was not the intention. I just want to show you all that at least something on what we can do when we start studying chemistry. So this is something I want to state from the very beginning so that we would have all the same level of understanding. And for your information, today there is not much chemistry that we will discuss. So no need to be afraid. So I would say, please take a cup of coffee or tea, sit back and just listen and enjoy the session. So let's start. I named the presentation as a journey through because it is really a journey through, but I am not the only one who has the same direction. Anyway, the idea behind this seminar from Assistant Professor in Chemistry, Dr. Manoj Lazar from St. Joseph's College was that we are facing currently a crisis situation. Therefore, all the students will have their insecurities and confusions, etc., about their career or future. Therefore, we shall plan something that will be helpful for the students to choose their career. And it was also clear to us that we cannot cover each and every option or topics. Therefore, we decided to present my educational career, like what I did and how I did it and what are my accomplishments, etc. So this was the thought behind, and this is what I tried to put into some slides, and I would like to share with you so that some of you could get benefited and may get some ideas. Okay, but do you know that each of you is a chemist? If you're studying chemistry, each of you is already a chemist. Do you know that? Because since the time you decided to start studying chemistry as a main field of expertise, from there onwards, you are all chemists. So doesn't it already make you a little bit happy or confident that you are a chemist? So when someone asks you, what are you doing? You can surely say that you are a chemist, but I need to study a little bit more to be an expertise level. So I'm doing that now. So, but during your studies, you will have questions like where to start, how to start, or what are the opportunities? Can I achieve my dreams and goals? Being a chemist or being in the chemistry field. And these are the things we will look into today. The first I want to say is that by selecting chemistry as a career, you have chosen one of the most widely discussed and popular subjects in the world. There is no question on that. So what you have got in hand is that you just got the license to travel the world. So I have put so many pictures which I took. Maybe this will get a little bit more of attraction from you, that you could visit so many places, because this is the most widely discussed topic, and a lot of researches, a lot of studies, etc. are going, a lot of companies are doing it. So you, with chemistry in hand, you could basically travel around the world. And this is the message I wanted to give you from the very beginning. And to start, I want to say that if I can do it, then you also can do it. in a way we all have to become. So to start with, about me, I have the primary education from a normal village type school. I was only an average student, sometimes below average, you know how it works. And during schooling, or during plus two, at this time, we never thought of doing a master's or something about that. I mean, it was coming from a very village type situation or atmosphere, so we never thought of becoming or doing something like that. Even during bachelor's, so we have joined, or I have joined the bachelor's, but still never dreamt of a master degree or a PhD. um, I mean, it was not really possible to get information, or nobody told us, okay, if you choose this path you might end up in like that. So these informations were not really or readily available during that time. So there was no real channel of information, or nobody thought or told how to dream or what to dream. Here I would like to quote a famous wording from Dr. APJ, that is, dream is not what you see during sleeping, but it is something that does not allow you to sleep. So, I mean, in my case, I felt it so many times. It's really true. But as an average student without any special skills or passion, it was difficult to find the line and get into that line. Maybe some of you might already be able to relate to this questions or confusions when you started bachelor degree or master degree, or even before, where will I go or what should I do. But I promise, stay with me for the next 1 hour or 45 minutes. I'm sure that you will be able to start dreaming from today, and that's what my hope, and I believe I could deliver that today. So as my career, I started, let's say, from bachelor's degree. So I did my bachelor degree in chemistry. It was during the time 2003 to 6, and I studied at the Mother College, Korolangad. It is a good institution, but until the point when I started the bachelor's, everything was very usual, except few points. I mean, what I got from this, the bachelor degree student life, you know, it's very cool. A lot of friends, combined studies, a little bit of talking. So it's a very nice period of time in being a student. A cool and supportive teachers with fascinating skills and know-how. I mean, I wonder sometimes, because they were so experienced that they didn't even need sometimes any textbooks or etc. to teach. So I was, being a bachelor student, I'm looking into that kind of teachers. So I also got fascinated. I mean, they're like amazing. So from there, I got my first dream. So I want to be one of them. So I want to be an amazing teacher. So this was the first thing came into my mind. And also during the bachelor's, the first opening speech of the first day at the Mother College for me, there was an opening speech by the principal, Reverend Dr. Agustin Palavkya. Maybe he told so many things, but nothing took into my mind or stayed in my mind. The only thing that stayed till now is he said, "Small aim is a crime." It's basically a quoting from, again, our Dr. APJ Abdul Kalam. So it still stays in me when I'm going demotivated or, yeah. So on such situations, you could think about it and digest it again. Maybe you will get more motivation and passion to walk again. Yeah, that's how the BSc started. But obviously, at the end of the bachelor's, you will have, everybody who completed will already had the question, what's next? Because we know that only with bachelor, or at least I knew that only with bachelor's, nothing is going to work on the way I want. So what's next? It's a very good question. So Master of Science, Masters is a must. Yes, I would say if you want to go further, it's a must. So you all have to go for that. So where I did my Master of Science in chemistry with a particular focus to organic chemistry. I did it in Mahatma Gandhi University. It's a small village kind of town near to the city of Kottayam. And in that university, I studied at School of Chemical Science. So this was an amazing place. So just few words for the bachelor students, if they're planning to do masters, how you could do that in School of Chemical Science. So we need to have the bachelor's mark list. It's also a criteria. There will be a national level admission test. So this you have to apply and write it. And there will be an interview also. And there are 4 different kinds of courses that they offer. It's inorganic chemistry, organic chemistry, physical chemistry, and polymer chemistry. So my major was organic chemistry. Even though the major is organic chemistry, only few subjects will vary. Apart from that, everybody study the same thing. So here I have a tip for you if you're applying. Once you clear the entrance exam, of course, you will get a call for the interview. But the performance on the interview has a huge or a higher impact than the total mark. So if you think, okay, I have 80% or 85% mark, but there are people with 90 or above 90% mark, that counts to an extent. But if your performance on the interview is perfect, then you might have a higher chance to get into that course. So why, I mean, from my point of view, why you should study here? I mean, this is what I experienced. So we have, or there is an experienced set of teachers. The teaching is theory and research oriented teaching, more research oriented teaching. And as an MSc student, you will be the junior most. So I put a question mark. So what? So being the junior most, I mean, if you do the masters in a university atmosphere, being an MSc student, you are the junior. So you will be talking to the research scholars, PhD scholars, or postdocs, and then after the professors or the readers or the lecturers will come. So you will be interacting with such kind of people, and this will already give you a lot of fascination and motivation, to my opinion. And during the classes, the practical sessions are mainly done at research labs, mostly supervised by PhDs or postdocs. So this is also very nice experience. They are performing the real-time researches, and a part of that will be given to the masters or MPhil students to perform as their laboratory work. So that's also a great experience. And also, if you are in that atmosphere, it is easy to get or easy to access international conferences. This is I would recommend as a must that you all should attend and make contacts. Maybe later on you will see how it transforms. And the final thesis, as a part of the master degree, is done or was done at CSIR labs or IITs or renowned central universities. So this is also a great exposure that you could work on only a research oriented institution, like CSIR labs are all research oriented. So this is also a great kind of exposure that you will be getting from there. And the tip is that where and what you do with your thesis can be a key to your next level. So when you apply for, you have to apply for the thesis to somewhere else, not at your university or outside your university, just to get more exposure. And when you're selecting, you have to select the professors or the research group that you are interested or that has the scope, and what topic you are doing. This all might have a little bit impact on what you will be choosing as a next level. So for me, I did the MSc project at Bhavnagar, Gujarat, and the institute it's also a CSIR lab, and it's called Central Salt and Marine Chemical Research Institute. I was there almost 6 months, and this was a wonderful experience for me. I mean, from here, I learned that how crazy and enjoyable can be the life of a researcher. This is absolutely true. I mean, all of the people or the students doing research or PhDs, they're all amazing. I mean, they do their hard work from morning till midnight. So I was also, I was doing only the master project, but still I was also a part of them. And it was so amazing. I mean, you have nothing else to do. You just go to the institute, either read or do the researches and solve different kinds of problems, issues. So it was really amazing experience. And they all have so much of motivation, passion, and a lot of interesting discussions and talks. So I must say that I was basically brought into a different world. It was not something I have never experienced before. And by looking at them, I reframed my dream. And then I decided, okay, I want to be one of them. I want to be a researcher. I want to have this fun what they're having now in research. And here I could give another tip. Wherever you do the master degree, it can be in a college, it can be in a university, try to do the project, the master project at one of the CSIR labs or at IITs or at a renowned research groups. I mean, here I have listed few of the CSIR labs and IITs. You could have a look later on. And for master projects, they mostly always welcome new students because they need new students. So you must apply at such institutions and get more exposure. This is what I would recommend to you. And in my master project, I did it under the guidance of Dr. Irinjalakuda Suresh, who was a great person, very humble and very friendly. I mean, I would never expected that he will come to the railway station to pick me up in Gujarat. Early morning, he came to pick me. It was such a nice person, and the institute itself was wonderful. And there, what I did was the synthesis and characterization of nitrogen donor ligands. So let's talk a little bit about that. What I did. So I have mainly used a technology called X-ray diffraction. So it's a single crystal X-ray diffraction. You will have two kinds. One is for powder kind of chemical substances to determine the structure. And second is a single crystal. So my topic was a single crystal. So I have to synthesize different ligands. We're using wet chemistry methods, and then I have to crystallize such materials to form single crystals. And these crystals will be mounted on the instruments that you're seeing here, and then run the crystallographic experiment. And from there, we solve the structure of the crystal. It can be a two-dimensional structure and also three-dimensional. So from there, we will get the different bond lengths and how the molecules are bonded to each other, whether there is an interaction or van der Waals forces between water molecules and the ligands. So this all will be or can be determined from such a technology. I'm not going into too much detail because this is not what the topic of today. So let's move on to the next one. So I told you so far so many stories about Mahatma Gandhi University, and you have to do that. You have to do the project. But maybe you could think that these are just stories, but I must say that it is not only about stories. In reality, so this is in this photo what you're seeing is my batch from 2006 to 8, and you could see that out of the 26 people, about 14 people did their PhDs. So this is really, really amazing. I mean, just to mention, there was one did at KUSAT, and now he is at Christ Bangalore, one at IASC, and he also don't even know where he's traveling now. From IASC Bangalore, he went to Australia for research for a few years. Then he moved to Denmark, and now I don't know, sometimes to Germany. So as I said, he's traveling around and enjoying the research. Yeah, and the two people at France, then IIT Kharagpur, Calicut University, and we have our first friend who joined at ISRO in Trivandrum, and at National Chemical Laboratory in Pune, and NIST in Trivandrum. So these are all options for you to, or you also to apply your master projects, and also there are options to do PhDs at these institutions. And there is one of my friend. She did her PhD in Germany and now studying at Bishop Moore College in Kerala. So maybe some of their students are also attending today's session. So it's really great that I could show this figure. So it's not only about stories, it is in reality, you could all do that. So now another slide about how you could get a master degree in Germany. And there is a lot of options to do master degrees inside Kerala, outside Kerala, or inside and outside India. But the MSc programs in most of the states in Germany are for free. So you don't pay like in the United States or in Canada, in Australia. You just have to pay some administrative charges and to get a travel ticket. So this is a very, very tiny amount that you will be paying. But the real money you need to have only for your stay, like home or food or such kind of things, you have to finance by yourself. So that will be the only thing. So apart from that, there is no real tuition fee, high amount of fees. I mean, there are courses that we have to pay, but I would say in natural science there are much less that we have to pay for it. So most of them are for free. That is the first advantages that you should study in Germany. And the internship and thesis are mostly mandatory, and this will be mostly paid. So the first 2 semesters you have to find the money for your survival, but secondly, thereafter you will have internship and thesis, and for this you will basically get paid from the companies or the university wherever you do it. And during the studies there are many options for work student. You could do a work student position. Many means you can work in the university in a research group doing a small part of research. So this is possible even during your studies. So you could basically help the researchers in some part and you will get paid. And what you have to do to get in here. So first of all, you have to find the right course and the university. So this is the first point. And there are, once you decided which course and which university, then you basically apply at the online portal or directly at the university, depending on the criteria. So there are 2 kinds of, either directly at the university, or secondly there is a portal called Uni Assist. They are supporting all the universities by getting the students, but that's a straightforward criteria. And there is an organization called DAAD, DAAD, and they provide scholarships. So if you decide the university and the course, you could check daad.in. In means India. So in this website you could check and you could find out more details about the scholarships, when to apply, how to apply. So all these could find out from here. And once the university admit you, then you will get an admission letter and just apply at the German consulate in India with the admission letter and some other documents which will be mentioned in the admission letter. So it's a straightforward. The tip is that make sure the university that you are looking in Germany, or the university where you studied your master's, is recognized in Germany, for example, and vice versa. If you want to complete your master's and do the PhD, and then if you plan to go back, then you have to check it vice versa, that the degree from this university will be recognized in India. So both cases you have to look depending on what you want to do. And another tip will be, I have seen that many of the people, they just go via third-party agencies and put a lot of money in them. Maybe you will get it, the positions, but to me, it's really unnecessary, because you will see that I also did the master's, but all what I did by my own. That's all. I mean, you have the internet in your hand and you could do the search. You could find each and everything. And there are a lot of forums or groups in the internet where you could ask questions if you have doubts or something. So this is also possible. So it's not really necessary to put a lot of money in third parties or agencies. That's what I would say. So the first master degree was finished. So what is next? Good question. Everybody will have, or maybe they already have. So my target, as I said, I want to be a researcher. I want to do PhD. So that was the target. So after MSc, my options are, you could write a NET JR for a GATE exam and do the PhD in India. But from my really good and friendly seniors, I could know that it's a very lengthy process until the goal is reached. It takes from years to years to complete the whole process. So I decided to do it abroad for 2 reasons. First thing it could be faster. I mean, the whole process, I mean, completing a PhD will be a little bit faster. Why? Because the institutes will be highly equipped, so there won't be any kind of delay between the analysis or whatever. So that's why it is much faster here. But getting an admission is a real hurdle. It is not so easy. I have tried it many times. But this is what are the options. But I know that it is difficult to get the admission outside. It will take time. So you have to apply, you have to make a lot of conversations, you have to do a lot of internet research, preparing CV and all these things. It will take a lot of time. But rather than just simply sitting and doing only that process, I thought, why don't I join the MPhil or try to join the MPhil course? And in parallel, I try to apply for the PhDs. So by this thinking, or from this idea, I started, or I applied for the MPhil course in MG University itself. And the criteria was almost the same as the master degree. So you apply, there will be a written test, there will be an interview, and then only you will get it placed. But I got the admission there. And MPhil is a 1-year course, a 6 months theory and practicals, and another 6 months is completely the project. And I started doing that, and in parallel I was doing a lot of applications, a lot of interviews, but nothing was I was not able to hit. I mean, it was not becoming real. In the meantime, I was passing with the MPhil. I did my MPhil project at both MG University and at University of South Brittany in France. So at MG University, my mentor, my guide was Professor Sabo Thomas. Maybe you might already know. And in one of the conferences, I met Professor Yves Groens, and he was also doing same kind of research. Then I talked with him, and then he gave me the opportunity. Okay, Subin, you can just come to my lab and do a part of your research in my lab. Okay, wonderful. So how did I get that? I was present in a conference, and before I joined, the conference, I did some pre-work. Sorry, there is a technical error. Okay, should be fine now. Okay, sorry for the delay. There was a technical issue reported, and I hope you all could listen to me again. Yeah, so I will continue with the topic. So I was basically able to do a part of my MPhil project at University of South Brittany together with Professor Yves Groens. I mean, these two people, they influenced in my life so much to choose and go with my career, that I must say. So the tip from the slide is that try to attend an international conference in chemistry during your bachelor's or master's, and make contacts and keep the contacts. I mean, they all will come, and everybody is looking for collaboration partners. They want to do the researches together, and this is how this, or the chemistry, not only chemistry, other field of researches are going on. I mean, one person cannot do each and everything, so they need partners, students. They're all looking for it. So, if an international conference is a very nice and good platform for the students, they could go and listen to the lectures from very senior research people and make contact with them. You could do a master project or something along with them in India or outside of India. So this is possible. So this will be a good one of the major recommendation from me to participate in such of the events. Yeah, I did at University of South Brittany. It was a very nice place. I did, or Professor Hughes Grohans was working at the research center named after Christian Huygens. Yeah. And what I did at the MPhil project, I did the synthesis and characterization of cadmium sulfide and zinc sulfide quantum dots. So to give a few ideas about this, a nanoparticle, you might all hear today's nowadays that or about nanoparticle. But what is a nanoparticle? I mean, every object has 3 dimensions. Width, height, and length, every object will have. But one of that dimension, if it is in the nano range between 1 to 100 nanometers, then we call it as a nanoparticle. So in the figure, you can see the first one is a 3-dimensional particle. So it has got a higher x direction, y direction, and is the direction. And let's say that if the y-axis is we reduce to the nano range, that means 1 to 100, then we can call this as a nanoparticle with 1 dimension into the nano range. So we call it as a nano wall. And if we can confine the x-axis also to the nano range, then we call it as a nano rod. So I mean, 2 dimensions are in the nano range. And finally, we have, if we confine the 3 dimensions into the nano range, then we call it as a quantum dot. So as a definition, you can say that quantum dots are 3-dimensionally confined nanoparticles. So this is what I synthesized, and I did the characterization and did the basic characterization of it. And for that, I used atomic force microscopy. This is also a wonderful technology to do some kind of quantification or quantitative studies and also qualitative studies. So the nanoparticles, or the synthesized nanoparticles, I coated on a silicon wafer, and then I spread it, and then using an atomic force microscopy, I did the characterization and find out what is the dimension of the synthesized nanoparticles. And from the graph, we could see that the 3 dimensions are below 6 nanometers. So this is a spherical quantum dot. So this was the my MPhil project I did in both Mahatma Gandhi University and in France. But ultimately my target, it was not MPhil, it was to do a PhD. So when I was about to finish the MPhil project in France, I got a call from another university in France, and they were organizing an international master program between France and United States. And what they offered me is that an integrated PhD position. An integrated PhD position means it is a 1-year master degree and a 3-year PhD or 4-year PhD work. So that's what it is called, an integrated PhD position. Nowadays, I think in India also they have at some universities they have such programs. So you do a 1-year master program and a 3-year PhD program, and into this you could join just after the bachelor's. But I'm not sure in which universities it is exactly happening. But you could check further. So such a position they offer me from another university in France. So I looked into the topic, It is a little bit more green topic. Eventually, everybody would move to a much greener solutions. In each case, wherever it is possible. I mean, mostly we cannot replace many of the stuff, but wherever it is possible, people want to replace it with green stuff. I thought it's an interesting field. Then I decided to join there. But I think from here onward, I would be talking mostly about polymers. So I would like to tell a little bit about polymers. As in the picture, you can see that there are lots and lots of applications where we use plastics or polymers in pipes or in paints, varnishes, elastomers like rubber bands, in plastic bottles, in automotive industries, a lot of car inside materials are made out of plastics. And in there is a picture with a lot of medicine. You might think what the polymers can do with medicines. This is nowadays a hot topic of research. Drug delivery. It's called drug delivery. Polymers that are suitable for drug delivery. So the idea is that the polymers will carry the medicine particles and deliver to the right part of your body and then dissolve the material. So it's also a hot topic. So there are also a lot of polymers are being tested and used. So polymers are everywhere, in simple, if we say it. I'm quite sure that you know the basics, but just to make sure, what is a polymer? It's made out of a something called monomer. Mono means one, meros means part, so one part. So monomer can be an atom or a small molecule that may bind chemically to other monomers to form a polymer. So it can be a same monomer. I have given few examples like vinyl chloride, styrene, methyl methacrylate. So if let's take vinyl chloride, what you are seeing here is one monomer. If you connect the same monomer one after the other, we get a polymer, and that is called polyvinyl chloride, and that is our PVC pipe or whatever. So like that, the polymers will be formed, and the monomer is the one single unit of it. The polymer, as I said, is a giant molecule or a macromolecule, you can call it, made up of thousands of repeating units or monomer units. Examples are polyvinyl chloride, polystyrene, polymethyl methacrylate. When we talk about polymers, what you have to keep in mind is that you will have distribution of the properties. For example, if you take molecular weight, it's not only a single molecular weight. For example, if I say, if you buy sodium hydroxide from anybody in the world, the molecular weight will be the same. So you can buy it from anywhere, but the molecular weight will be the same. But if you buy the polyvinyl chloride, the PVC from company A till company C, you might have different molecular weight because it's always a distribution, and this distribution is basically controlled by several factors: reaction time, catalyst, properties of the catalyst. So it's always a distribution. It can be the monomer distribution, different monomers, a distribution of different monomers. So when we talk about polymers, there are a lot of distribution. That's make it much complex to make characterizations and analysis. But a lot of people or researchers, they're actively doing a lot of things with it. Just the last slide about the introduction to polymers. If we classify it from the source, we have natural polymers and synthetic polymers. Natural polymers like cellulose, proteins, carbohydrates, starch, these are all natural polymers. And in synthetic polymers that are typically derived from petroleum-based products, or it was synthetically made by scientists or engineers like nylon, polyester, epoxy, etc. So coming back to my Master of Science in France. So after my MPhil, I joined for this Master of Science. It was at University of Rouen or Université de Rouen. And the subjects that I studied was material reinteraction, thermal analysis, dielectric spectroscopy, material characterization, etc. Since they took me as an integrated PhD student, I had special privileges. So I had a place in the lab. So after my classes from the master degree, I have to directly go to the lab and start working there. And the person what you're seeing in the photo is a great human being, Professor Dr. John Mark Sater, very wonderful person again, who motivated me so much. But okay, just I will come back to it. What I did there in that master degree was fabrication of green compost. I said it's green. So what they did was they took wheat flour and rice flour and then mixed it with different kind of fibers and make thermoplastic composites out of it. So rice and wheat, it has starch, and that's already a thermoplastic. So if you eat rice, you are basically eating a thermoplastic. Okay, now apart from the joke, so how to make the composite? So we have the flour, it can be rice or wheat, and there is a lot of additives are needed to be added for the smooth processing and the stability of the final material. Then we add the fibers will be pre-treated. Depending on the application, it will go through an extruder, and then we get the pellets that you see here. And these pellets will go again through the extruder, and then for the final composite will be made depending on which mold we will put at the end. So I have two pictures here, rice and bamboo composite, and then I have the rice and flax composite. So the green composites can replace plastic from some applications. As I said, polymers are used in many of the fields, but we cannot replace all of them. So, but by doing research and finding these type of new green composites or biodegradable composites, we could replace the application of plastic to some extent. So that was the idea behind. But unfortunately, I had to come back to India after this master's because Professor John Mark Sater, he applied for a funding for me to start my PhD, but it was not got sanctioned at the beginning. But then he told, it's just a matter of time. Now you have to go back, but we will get you back into our lab. And during my master degree here, it was fully paid because they thought I will be continuing as a PhD student. So for my master degrees and the MPhil project, I paid nothing, not even a single penny. Even my flight tickets were reimbursed from the institutes. My accommodation was paid, and I got another some hundreds of euros for my personal belongings or living. Yeah, this was possible, but I had to go back to India, and I was back at MG University, and we tried several stuff. But in between, one of my friends from MacFast, Marathanesia's College for Advanced Studies, Tiruvalla, he told there is a project from Department of Biotechnology, and the project is on integrated technology for the production of reinforced bioplastics with cellulose of plant origin. So this is more or less the same what I did in France during my master. So I thought, okay, until the PhD, the funding, everything is getting ready, maybe I could work on this project because it's almost the same, but different material and different floor and these things. And there, what I did was extraction of cellulose fibers. It was a jute fiber, nice experience. And using wet chemical treatments, we cleaned up the fibers and modified the functionalities around the fibers, and then fabrication of the composites, and finally the characterization using scanning electron microscopy, some mechanical characterization, finally molding of products. But I was not there until the end of the project, but I came to know that they made some really interesting final products out of these materials. Yeah, during this time, I was waiting for the call from France, but I was not simply waiting. I also applied for another positions, and then one day I got the call from Germany. Initially, it was called Deutsche Kunststoffinstitutszentrum or Deutsche Plastic Institute in Germany, and they told they have a nice position. I look into it, It was an application field, characterization of polymers again, and it looked interesting to me. And then I decided, okay, I will come to Germany. So I just applied via online, and yeah, my guide, he just reviewed my application. He directly called me for an appointment to have a small talk. So they don't say interview; it was small talk. And then yeah, basically he was fine, and I had good references. I had references from Professor Sabu Thomas. I had references from John Marsater. I had the reference from Gujarat. So all this made my application really strong. Then I came to Germany. But if you want to find out, I can list it up some details how you could find it. So to do a PhD, so first of all you have to find a position. Finding a position, it's done just online. So you go and you search there at different platforms. Maybe some of the slides later on will explain. And then you apply to the professor or the designated person with the CV and other documents. Simply straightforward procedure. If it is approved, you will get a contract. And since you are doing PhD, you don't have to worry about any kind of money that you have to show at the consulate to get a visa or something, because in the contract it will be mentioned. If it is a paid PhD, so this you have to confirm it. If it is paid, then in the contract it will be mentioned. You just make an appointment at the consulate, go there, show the contract, and within, I don't know, period of time, you will get your visa, and then you just fly. That's it. I can offer a tip. When you apply, it's not only for PhD, it can be for any kind of jobs or whatever. You cannot have an ideal CV and cover letter for all applications. This does not work, at least for me or from my experience. You have to modify the CV and cover letter each time when you apply according to the advertised position. So if there is an advertisement, there will be different points listed that the company is looking into a candidate. Means the candidate should have this. There will be so many. But if you look once again close to it, there will be only few points that are really relevant for that position. So these points, if you have experience, these points should appear in your CV and in the cover letter. Because assuming there is an open position, maybe 100 people are applying. I mean, it's not really possible that they go into the details of each CV or cover letter. It's not possible. So they filter it. How do they filter? They filter it with keywords. So if these keywords are coming into the first paragraph of your cover letter or directly into your CV, you might get a better chance that the hiring manager or they will look into your CV or cover letter. So just as a tip. Yeah, of course, the key to success is that try until you hit. It's not easy. For some people, it's very easy. For example, one of my friend from my master degree, he applied only for 3 positions and he got one in France. So lucky. And some others like me, we were continuously applying, trying to find different channels and different options to get into the place where we wanted. Yeah, so try until you hit. It does not matter to be in one direction, so you can go around if it is not working directly. So but you have to try it. Yeah, that's all. Try until you hit. Yeah, here are some links or some names to find the PhD poll. You can look into these links like research in Germany or that in India. In India, there are the process how to apply, where to apply, when to apply. You can also look for courses that are taught in English. I mean, this is especially for master students. Not all master degrees are taught in English. Some of them or most of them are in German. But there are English courses also for chemistry in Germany. So this you have to look up. You have to look at the language of the course. If it is a master degree, if it is a paid one or non-paid one, mostly it's non-paid. So you have to put a little bit of attention there. And another two links are also here. Yeah, you can also try directly in Google and try to search open chemistry PhD positions in Germany 2020, 2021, something like that. And yeah, make sure that the position is funded. The best way is to use the contacts made from conferences. This is always the best option because they know you personally, they know your face, and this will be much easier to get in contact with the people. And for PhD, German language is not mandatory unless they really specify for it, because research is mostly international, and English is mostly fine for it. So in my PhD, I did at Fraunhofer Institute. Initially, the institute was called DKI. Then it was merged to Fraunhofer Institute. It was named after Joseph von Fraunhofer. And the Fraunhofer Society is a research organization with 72 research institutes, each focusing on different fields of applied science. But still, it's applied science, 72 institutes spread over Germany, and each of them are doing amazing research. All of them are practical oriented, applied oriented researches that they are doing. I did it in from 2012 till 15 time. And okay, now I will talk a little bit. It's not really chemistry, but what I did. What I did was quantifying the effect of processing and deteriorating environments on polyolefins. Polyolefins are made out of petroleum products. Polyolefins are widely used around the world for so many applications. So there are three categories. Maybe I don't go into the detail of each of them. As an introduction, polyolefins, what is it, thermo-oxidative degradation, a little bit about welding, and then methods, different methods which are used, and a little bit about the characterization. So polyolefins, as I said, it's around widely used. Then the two major players are polyethylene and polypropylene, like polyethylene pipes or other materials in automobiles, in packaging industries. So many places it is used. But every day the company, they are trying to put up something on top, a new material with new or high properties or high tensile strength, high hardness. So they're always tuning the properties of the polymers. So the research is everyday ongoing process, and it never ends. So you will always have your chances there. So before I come into this slide, if a polymer product is being used somewhere, it will be in contact with atmospheric conditions. It can be under sun or under rain or under heat. And that's one thing. So the polymer can degrade. I mean, this is not a problem for us, but it is a problem for the producer of the material. They don't want their material to get degraded or destroyed very fast. So they want to know why it is happening, how it is happening. So this is also a very interesting topic of research, and this is what I did. I studied how the degradation in polyolefins happening, what can we do to prevent them, and what things are degraded. So this is a life cycle of a degradation process. So RH means polymer. So we have the polymer here, and R with the star, I mean it's an alkyl radical. So when the polymer is in contact with the UV, means sun, in presence of oxygen and heat, it generate an alkyl radical. So into a polymer product, we add something to stop this one, otherwise it will keep going. So we add something called radical scavengers. So it will give a hydrogen atom, so it will come back to the polymer state, so no degradation at all. So we can prevent it. If it is not prevented at this stage, then it's again joined with oxygen, and then hydroperoxides or peroxy radicals are formed. And this one can also be scavenged or deactivated by the radical scavengers by donating a hydrogen atom. If it is still not possible, then another hydrogen donor, or it takes a hydrogen from another polymer, and that will become a radical again, and then this loop could be continued. If it is stabilized, then we get a hydroperoxide, but this has to be decomposed. This will be decomposed in presence of heat to alkoxy radicals and hydroxy radicals, and the cycle could continue. So this is the process that is happening into an oxidation or oxidative degradation of a polymer. But to prevent that, a lot of things could be done, and we could also study what is happening. So in a life cycle assessment of a polymer, so here I took a sample. You can see a black spot on the sample. So this could be mapped using infrared microscopy. We did it in transmission mode, so we could do the quantification. So this was a simple optical microscope image, and we mapped this area and did the quantification, and we checked which material is higher in what place, why it is degraded, which material is degraded, and if you match it, it's perfectly matching with the result. Another one was the degradation of a pipe. There was one with unaged, that means it was not used. Another one, it was used, and you can see a lot of white particles. So we analyzed these white particles with infrared spectroscopy, and we find that the polymer peaks or bands are there, and there are also some degradation products like ketones or gamma lactones, etc. And then we did a chromatography analyzer. We did the molecular weight analysis. We find out that the initial layer has a very low molecular weight. So that means in some of the previous slides, I said a polymer is made out of monomer units connected one after the other and forms a long chain. In this long chain, if it is degrading, that means the long chain is broken into smaller pieces. So what will happen? Long chain has a high molecular weight. If it is broken, then the molecular weight is low. So if we use a technology to determine the molecular weight, then we could directly see whether it is a degradation product or not. And then another thing was the orientation of polymer chains. The polymer, as I said, it's a long molecule, but it is not always linear in shape. It can be coiled together in a nasty shape, like what you can see here. But if there is a tension applied in both direction, it could be into a nice form. And this is what is happening during the processing of various polymers. Maybe with this explanation, you might not be able to relate to that, but I can give another example. So there is a pen. You see, it's a long one, and there is one arrow that is the direction of the machine. So that means the polymer comes into the mold and it forms this shape. If you want to break it at the middle, so we just bend it, we can break it. But by pulling from the two sides, we cannot break it. Why? Because the polymer chains will be keep extending, and it won't be broken so easily if we pull it from the two sides. So that's the benefit of having, or to know why or in which direction the polymers are oriented. So we use it's called a theory of dichroism. We use a simple light, and we use a polarizer, and the polarizer just put through this light in only one direction. And if there is a molecule with a dipole moment at this direction, it will give an absorbance. And there are some equations, maybe it's not so of importance. You might get the presentation later on. You could have a look of other questions can be answered later on as well. So I quantified the orientation in a welded material. So welding is a well-known processing technology that is widely used. So welding is not only for metals, it is also used for polymers. A lot of so this is a welded material. Two plates were joined together at the point where it is melted and contacted. The polymer is going in both directions. So to find out what is the extent of orientation of the polymer chain, so we have a machine direction. That's what you see here, and then direction perpendicular to that, and then we have another direction, that is the flow of the melt at the weld region. So if we can name it, we have three directions: the machine direction, the transverse direction, and the normal direction where the melt flows. So we took a small piece from there, and we did a polarized light microscopy, and we have the the picture of the welding region. You can see that there are two seams, weld seams or the melt flow regions, and going on. So we could name the different fields like injection molded plates on the left and the right, and the flow lines are called weld seams, and in the middle it's called weld core. And a small part was selected, and in this part we use infrared microscopy again, and using the theory of dichroism we could determine the orientation at each. So MD is the one direction. We know that at this point the melt is flowing into two directions, so the orientation is different. So that's what exactly we hear in the MD direction. When it comes to the weld seams, it's flowing into a different direction, and we could calculate it for the three dimensions, and we see that the high orientation is in the normal direction. So this is absolutely possible to determine and quantify, and that's what one of my topic. And thereafter I joined as a product specialist. This is what I am currently doing at a company called TOSOH Corporation. TOSOH was founded in 1935. It is a diverse chemical company with a lot of basic chemicals, petrochemicals, specialty products. And under TOSOH Corporation, there are 107 companies spread over 19 countries. So it's a very huge company. You might also hear it. We have one branch in Cochin and in Mumbai also. So it's a very nice company. And here what I do is only chromatography. So this is a slide just talk about a little bit about the chromatography. If we have a polymer, the molecular heterogeneity, I said we have the molecular weight distribution, comonomer distribution, etc. So the molar mass distribution and the chemical composition distribution are the two heterogeneities in a polymer. The chemical composition distribution is mainly determined by interaction-based techniques or crystallization-based techniques. I'm not going in detail to that. Today, the focus will be the molar mass distribution, and there are two kinds of techniques, and in that too we will be focusing on something called SEC but GPC. If there are any bachelor students in this chat room now, I just came to know that in the 5th semester they have a topic about gel permeation or size exclusion chromatography. So it might be a little bit interesting for them. A few times size exclusion chromatography, we call it as SEC. And SEC is a combination of GPC and GFC. GPC is gel permeation chromatography, GFC is gel filtration chromatography. So if you could ask what is the difference between GPC and GFC, it's only because which solvent we are using. If we use an organic solvent, we refer the technique as GPC. If you use an aqueous solvent, we refer the technique as gel filtration chromatography. Yeah. So this is a small animation how it works. So in a GPC or SEC technology, we need to have the solvents, we need to have the pump that run the solvent, and there should be a column line. And after the column, there will be a detector coming in. So the analyzed material, it can be mostly a macromolecule, and we want to determine the molecular weight on a first hand. It can be also that we just want to know the separation according to the molecular weight. So the separation of the molecule happening in a column, then the columns are packed with gel particles, and this, okay, so now it's clear. So what you're seeing here is the gel particle which are packed in a column, and when the polymers with different sizes, as I said, we have the molecular weight distribution with different sizes. Oh, sorry. With different sizes, these gels contain a lot of pores, and the bigger ones or the bigger polymers or the bigger macromolecule cannot be able to go through the pores, but the smaller ones that will go through the pores. So you can see that this is how the separation is happening. So the red one was the biggest polymer that will be detected in the detector first, and you will see a corresponding peak here. So and followed by the smaller ones, and the smallest particle will find the longest route because it can go through each and every pore because the size of the molecule is so small. So now the separation is happened according to the molecular weight, and the separation happened through a column, and then after the column there was a detector. It detect the separated material, and from this data we can determine or we can calculate the molecular weight. Maybe you will study it when the course starts. So moving on, I think that was the introduction or the journey, but a few more slides about why you should come to Germany or to come to Europe, or what are the opportunities. For that, I thought I would present the history of the chemical history of Germany. From an industrial point of view, it does not exist now, but in the past it's called Interessant Gemeinschaft Farben Industrie AG, or simply called IG Farben. So IG Farben was the largest chemical and pharmaceutical company in the world when the 1990s started. But it was then split into so many small companies, but all are still existing in Germany. Like Bayer, BASF, Hoechst, BASF is the second big chemical company in the world now. The first one will be Dow DuPont, and then Bayer, Clariant. There are a lot of small size and big size raw chemical polymer companies, polymer intermediate producers, final product producers. So lots and lots of companies and lots of research institutions. Yeah, when it comes to academics, so far there are more than 30 Nobel Prizes only in chemistry, which were owned by the people from Germany. So this shows how how intense, detailed research in chemistry is going on here. So if you want to be a part of that, obviously you have to look for how you could do that. So I have given a lot of options, examples, where you could work on it and find your career. And there is also a great number of applied and fundamental research organizations. It is impossible to go through all of them. But like Max Planck Institute, it's same like Fraunhofer Institute. Fraunhofer, there is also already 72 institute. Max Planck, I think much more. They have a lot of institutes spread over Germany. So this is only the case in Germany. There is a lot of options in France and in Belgium, Netherlands, or in Austria or Switzerland. These are all independent companies, and they all do different kinds of chemistry a lot. So why I tell you all this, of course, there is a huge opportunity out there, no question on that. Now the call is yours. Do it wisely. And the the puzzle between you and the success is basically in your hand. So you have to decide whether you want to join it or whether you want to place it or correct it, and you want to walk towards the success or not. So the call is yours. Do it wisely. Yeah. From with this, I would like to thank all the participants. So it was nice that I could show a lot of things, but still not all. But yeah, some of them we have covered. So if there are any questions, we could start with it. I could try to answer some of them. You can use the chat option in the question answer session in the platform to ask different questions. Maybe to start with, I already got some questions in hand. Maybe I could start discussing with them. One question was the language requirement in France and Germany. So as I said, for PhD, most of the time you don't need. Okay, maybe I shall open. Yeah. So now you could see me better, basically. Yeah, as I said, for Germany and for France or other European countries, to do a PhD, it is not mandatory to have their own language because research is something international. But sometimes the professors or the guides they stick on to the language. So in that case, it will be difficult. But for masters, when you apply, you have to really look into it, in which language the course will be taught. So that is the one. But if you know the local language, your personal life or the general living and the social communications can be good if you learn the language. And also, if you want to start a job, you need to have a basic level, but that you will get if you do a master degree. There will be language course in the master degree, and also during PhD you can take so many courses from the university. So by the time when you finish it, you will have some basic understanding and you can basically work on that. The second question what I have here is the scholarship for master degree, PhD, and especially masters. The scholarship for master degree would be you have to look into the DAT scholarship, and as I said, there is no real tuition fee or something. You have to pay only some basic investment. Yeah. And the third question what I have here is the job opportunities. So throughout the slide I have shown so many of it. Yeah. And another question what I have is the masters from there is advantage for getting job or PhDs. Yeah. So a direct job, if you try to get directly a job here, it might be much difficult because the people here, they don't have the system like hire and fire. This is not the way that things work here. Once they hire you, it's like they need you, the companies or whatever, they need you for a very long time. So that's the mentality is working here. So they want to know you have to prove them that you will stay here for some time. And that's why it does not work if you directly apply for a job from there. But the best will be either you do a master's or PhD here and then start looking for a job. Then they know that okay, you were here for some years, and so this is basically already a good proof that you will stay here. Another question I have here is the tuition fee for science master degree roughly. So there is, as I said, there is no tuition fee. You pay only 250 or 300 euros. That will be 20,000 Indian rupees, 20,000 Indian rupees per semester. And in this one, you will have a travel ticket depending on which region you are. And yeah, that's the only thing. The rest will be your accommodation and your basic living, food, etc. This you have to look by your own. Another question I have here is, do you think opportunities increase or decrease? I mean, the opportunities will always be there because the companies, they need people because they have a lot of things to be done if they want to improve their products and all. So I used to hear that there is a lack of experienced professionals. Even from my company, I used to hear that it is very difficult to find the professionals. So there is basically a lack of people. So you should try for that. The COVID scenario, yeah, now in Germany, it's much better. I mean, since some time, everybody is a little bit relaxed now. Everything started moving forward, started working everything as usual, but with some restrictions like what we have, like mask or something. But yeah, the situation in general, it's moving forward. So how to get permanent residency? How to get permanent residency? So to get a permanent residency in Germany, you have to pay the tax for 33 months. If you're a science stream, your salary should be more than 38,000 euros per year. So this, of course, you will get it. Uh, just a second. Yeah, sorry for the delay. Yes, yeah, sorry. I thought I'm sharing my video camera, but I got the notification from the organizer that only my slides are being viewed. But at least you could hear me, so that's already good. So moving to another questions. Yeah, how to get a permanent residence? So you have to be here for some time, and when you get a job, you have to pay the tax for like 33 months, and then you can apply for it. But when you apply for it, you need to have a certain level of German language, like B1 language of German proficiency you need to have. But that's all easy. It's easy. And let's complete his courses. Can he build his career in game? Okay, there is a question from Sachin Kumar, a student of MSc Chemistry. If he completed his course with 60% or below, 60%, can he build his career in chemistry? It depends. It depends. I don't know exactly what are the limits, or what are the expectations of the marks from masters in Germany. You do a master's with 60 percentage. Yeah, you have to look into it. Ideally, in none of the, yeah, just a second. Okay, sorry. This was another notification for me. Yeah, it depends. In if there is a PhD position advertised, there it is not mentioned that how much mark you should have. You basically have to apply and check for it, or you just write beforehand and then check with the respective person that what is the admission criteria for the university. But this is all should be possible, I think. Taking integrated PhD rather than taking MSc and PhD separately. What do you think about taking integrated PhD rather than taking a MSc and PhD separate? Yeah, integrated PhD is it's completely fine. I don't have any negative opinion on that. In my student, in my institute where I did my PhD, there was few students from IIT Kharagpur. They did polymer chemistry there, and it was an integrated master degree. So that means the bachelor and master degree is completed, and then they move to the PhD. So if you do an integrated PhD, this is also fine from my point of view. Anonymous. Okay, there is another question. What are the drawbacks of doing PhD abroad? Is it difficult to get a PhD, especially in academics after doing a PhD from abroad? Okay, education is basically a pyramid. When it's like a pyramid. You start from a very broad range, and then you specialize, and specialize. So it's like a pyramid. When you move to the top of the pyramid, it's becoming narrow and narrow. So it's similarly your job opportunities are also little bit narrowed. That means you are a very specialized expert where you can look for job in that field. I mean, of course you can change it a little bit, but in general maybe you could relate to that. So this is a pyramid. I mean, there is no disadvantage if you do a PhD and the field where you worked in, if it is relevant and a lot of research going on, or there are companies who are working on this field, then of course you get jobs. This is absolutely no issue. And doing PhD abroad, I mean, what is the drawbacks? I don't see any drawbacks in doing, because I know there are a lot of people that did PhD here in and around Europe, but finally they wanted to settle back in India, and they did it perfectly. The only thing is that in my presentation, I mentioned whether the university where you did your PhD in Europe, is it recognized in India? So you have to get a recognition letter from I don't remember the organization, but it is somewhere in Delhi. And then also you have to get a equivalency certificate from the university where you want to start your career. So that is the only thing. So there is no real drawbacks. If you want to get into academics here, not in companies, in academics here, then in PhD you need to have a very good credit, and the credit means mark. Yeah, mark. Is basically how well you written the thesis, how well you have presented. So if you have a score of 1, you can apply for an academic position here. Yeah, this is fine. Please explain MSc biochemistry. So this is another question. This is also a wonderful topic in biochemistry. A lot of things are happening. There are a lot of biopharmaceutical companies, and there is a lot of bio-related research happening in the universities and research institute. This is also a very hot topic, and yeah, lots and lot of opportunities, I must say. It will be great if you can tell me about the keys to transform from academic to industry. So, okay, if you do a PhD, this is fine. If you do 1 postdoc, maybe this is fine. But if you do a 5 postdoc and you wanted to go back to the industry, this might be difficult, because in the industry they don't really care how many publications you have. They just don't care whether. I mean, they just look into you. Do you know what they are looking for? Can you do that job? Are you intelligent enough? Are you versatile? Are you belonging to a teamwork? So these are the things they look into it. So changing from academic to industry, yeah, this is absolutely fine. This is what I did. I did my PhD and the masters, and thereafter I decided to join for the industry, and this is what I did. Yeah. So I am the living example for that. So please share information about fellowships. Fellowships, I said that fellowship for masters and PhD. For PhD, lots and lots of fellowships. You don't have to apply for the fellowship, but the position itself will be funded. So when you find a PhD position, you have to check whether it is a funded position or not. Mostly it is funded, otherwise they don't really advertise. But there are positions, open position, that if somebody wanted to do and have a different kind of funding. Another postdoctoral program. Okay. I want to know about the postdoctoral program in abroad. I mean, I was not really interested in doing a postdoc because there is a lot of insecurities. The postdoc can be for 1 year, 2 year, or there are postdoc I know it's going for 5 years and more. But after that, what? So you want to finally settle down somewhere. That was my idea. So after the PhD or during the PhD itself, I have decided I will directly join at the industry. So, and that's what I did. But to do a postdoctoral program, yeah, this also will be advertised in Helmholtz Centrum or in Fraunhofer and Max Planck in universities. There is a lot of places where you can do the postdoctoral studies with the PhD in hand. Okay. Project in which magnetic nanoparticle used in the separation of medical kit development as a chemistry student will that task is difficult or it's fruitful? Okay, there is a nice question. I'm planning to do a project in which magnetic nanoparticle is used in the preparation of medicinal kit development as a chemistry student. Will that task is difficult or it is fruitful? I would say even if it is difficult, what is the point? You can do it. No matter who is it. It's a nice topic. I think in medicinal kit, so there is a lot of value added. I would say whoever wrote that question, they should attend it. And how much an industrial background helpful in doing PhD in European? Industrial helpful in doing PhD. I mean, to do a PhD, industrial background is not necessary. You just come directly after the university. But if you have an industrial background, this is still okay. This is also not an issue. If you want to do a PhD and if you could really show that you are motivated, then yeah, it's fine. Is this process is successful an average student? It's not only for average student, but it works also for average student. But you see, yeah, we have to try directly, indirectly, using contacts. This is all the factors. So you have to try different ways. And in the presentation, I give different options what you should try. That is a major unique job opportunity. Sir, I'm interested in doing chemical engineering after my BSc. May I know the further details? That is a major university and job opportunities. Yeah, this is something I said. The first position is that you have to find your course and university. So basically, you need to do or you need to have the motivation to do some homework. So this, without this, nothing will work. I mean, I can tell you some examples. Some people they say, okay, can I do that? Can I do this? Can you find this? Can you find that? I mean, okay, this is something they have to work on. Okay, whatever I know, I can tell, but there might be hundreds or thousands of things which I don't know. So this I cannot provide. If they just ask me and do no work or homework by their own, then I do less chances of getting successful. So if you really want to do it, you do the homework like Google search, find the university programs, forums, or contact the people. This all you have to do. Just simply sitting and asking somebody to give something. I mean, this does not work. So you have to really work on it. How can we join IAC after MSc Chemistry? So if you want to join IAC after MSc Chemistry, basically I would recommend to start your master project at IAC. So this will be an easy entry for you to IAC. And then depending on whether there are projects already going on, they need somebody to work on it. It has to be advertised. I don't know how the advertisement working there. Maybe it's mostly via contacts. So there you can apply, or if you want to do a PhD, you might need a JRE net, maybe not sufficient. You need to have a JRE, or you need to qualify the JRE to get into IAC. I want to ask you which chemistry is good for doing masters and the opportunity it provides. I mean, each of the chemistry is equally relevant, but maybe if I comment on that question, others might get disappointed or something. So if you look, I mean, the application is everywhere. Maybe the percentage of application may be varying a little bit here and there, but each chemistry is equally important. Maybe you could do a little bit search on what are the hot topics of research in chemistry, then you might get an idea on which field you should do your masters and PhD. Scholarship are needed to do PhD outside India, but how can we get that wisely and faithfully? Okay. To do, as I said, to do a PhD, you just need to find a position which is funded. So you just go to the links which I have provided, and there you can find a lot of things. And there will be a way how you should apply it. It will be mentioned. So when you're applying, or a contact details are already given. It can be a phone number, it can be an email ID. So you directly ask them whether this, okay, I am so and so, I am interested, but can you please let me know if it is already funded position or something. Then you will get the information. So you don't need that to apply for any special scholarship by your own. That is the easiness. If you want to do it here, you just find the position, ask them. Most of them are funded. Yeah. So that's an easy way. You don't have to look for any special scholarship from India or from anywhere else. You can directly do it here. I'm a PhD and several postdoc experience, and I would like to transfer my career in this. My experience is various applications of MOFs, experience in crystallography, thermal technique, ICP-MS, molecular spectroscopy, etc. So PhD and postdocs, so as I said, in industry publications, they don't really count because they don't publish too much, because most of the data are secret to each company, so they don't really want to publish. Only the things or the advertisement, that's the only thing they will publish. To do, I mean, you have to look for the positions first of all, where you want to do it. You have to apply for the positions with the documents required, and then you have to do the follow-up. This is a very important step. If you don't do the follow-up, okay, I applied, okay, let them contact me whenever they want. No, you don't get it. If you follow up, or before applying, you make a contact to the person. You can look into LinkedIn, who is the HR manager of TOSOH Germany, something like that, and then make a contact, ask them, okay, and so I would like to ask few questions about this advertisement about a job. So these things you have to do. It's not simply that you put your application and wait. No, it's not like that. In Germany, at least, LinkedIn is a very good platform to search for jobs, but again, this is not a Facebook. This is mostly working for professional things. You can add headhunters into your contact list, means you can add recruiters into your contact list, and if there is an opportunity, they might contact you. So you have to try different things to get it successful. There is no one way. Can you chemistry that have, okay, can you say different branches of chemistry that have much scope? Yeah, I did polymer chemistry and I am really successful here. If there is organic chemistry or bio-organic chemistry or biochemistry or even inorganic chemistry, there are lots and lots of companies, they produce inorganic based additives, and yeah, lot of research fields are in inorganic chemistry and also in physical chemistry, a lot of characterizations. So all branches have its own scope, but yeah, what you do, where you do, how you do, and how you make contacts, how you are active in the field. So these are the things that decides finally to get some opportunities. So how could we join? Should we show? Okay, how could we join MSc in abroad? Should we show IELTS score? High fee will be there. Okay, IELTS score, it depends from university. I would say it should be a must. IELTS 6 or 6.5, it's not a big deal. If you spend 1 month, you get it easily, because I am pretty sure that you all are not so silly students. You're all intelligent, so you could easily get that. High fee will be there for masters, for MSc. Okay, for masters, no, I said no. I mean, at least in Germany, most of the universities are for free. At least the course, but the living you have to find your own ways. I'm an MSc student. I want to do work as a chemist. PhD is also in my mind, but therefore I wanted to work as a chemist. Therefore, I wanted to work before that. I wanted to work as a chemist. Yeah, okay. So you just finish your masters. You can look for companies. Maybe I don't have any recommendations for now. Which companies would be suitable, but you have to look for it. You just have to apply. And maybe if you have few years of experience from the industry, you can come back and do a PhD. This is also fine. What are the requirements for doing a PDF there? I think this is also varying from group to group and also from universities to universities. Is reference always important for applying PhD? Yes. I would say you need to have reference, because the professors or whoever it is abroad, they don't know you personally. So how could they know you? You are a intelligent person or a hardworking person, whatever. I mean, what are the ways? Just with the application, they cannot find who are you or what kind of person are you. So if you put a well-known reference, then the people from here, they will contact the references you mentioned. They will ask about you, whether you did a good job or a good grades or a good study during the time. So you need to add good references and well-known references, I would say, if possible. I completed my master's, but I don't have any research paper publication. Without that, I'm unable to apply for any PhD. No. If you have a master's, nobody expects you to have a publication during master's. No, I don't understand who said that. To apply for a PhD, publication is not a criteria. Okay, if you have it, it's good. If you don't have it, this is also good. So basically, you need to have the mark, you need to have the reference, you need to have the contacts. So with that, you just ask why your contacts, whether there is a PhD position open. If there is something, you get to know the field, and then you just apply for it and you get it. Just a second. I'm getting some messages from the coordinator of this event. Okay. The message was that somebody asked what are the opportunities to do a PDF, how to do it, and what will happen after the PDF. So the coordinator, Dr. Manoj Lasser, he just wrote me a message saying that there will be another session with a person who did a PDF in Europe, and he is settled in Europe now. So maybe he could contribute much more to that question. So this is just an information I just got from the organizer. So it's again another question: is there any scholarship available for PDF? I think it's a question for the coming session. Is there an entrance exam to get master's degree or PhD? Depends where you are doing. There are some courses which are heavily populated, means a lot of people are applying. So if you think from a logical point of view, how could they identify it or sort? So they conduct an entrance exam. But for PhD, no, there is no entrance exam. It's only based on your master's and master project, what you did, and the PhD is also similar field or something. So these are the criteria. No entrance exam for PhD. Is it easy to get a postdoctoral position? I think this is also a question for the next session. So there is one question: how one can contact you, sir? So just a second. The easiest will be you contact the organizer. The organizer can send a follow-up email either with my contact details or their contact details. And if you have any questions, or I mean, there are so many questions here, maybe it's not possible to answer all of them. And I could later on collect these questions and put in a file. Then later on, these questions can be answered. Maybe Dr. Manoj can give a short comment on this, and then I could tell it to hear whether this way will work or not. Okay, another question: after doing a PhD in Germany, is it possible to move to other countries for jobs or research? Yeah, this is absolutely possible. A job is something you could do anywhere in Europe, at least. So the movement is not it's not restricted. The only thing is that you need to apply and get the job and get the contract, and you have to apply for the visa to which country you want to move on, and then you just start with the process. The postdoc. How they? So another question: how they filter the students for the post of postdoc? So this will also be a question for the next session. PhD necessary jobs industries abroad. Somebody asks, sir, I'm not interested to do a PhD. Is PhD necessary to get jobs in industries abroad? How we could get a job without a PhD in abroad? Okay, the best would be you come and do a master's here. As I said, a direct job application from India might not work because the people here, they don't know you, who you are, how you are. So this will be tough also for the visa processing. But if you come here, do a master's here, then apply for a job, you have a much higher chance. I mean, I'm here since 8 years, and I have seen a lot of students, master students, and I have seen 99% of them, they got a job here. So this is all what I can say. Just a second, I have another message. Okay, I have received the message that regarding the contact and answering other questions. Yeah, what I said is basically agreed. After the session, we will collect all the questions. I hope we will be able to collect all the questions, and then we will find the answers to that, and then the coordinator will send a follow-up email to you. Place our time with chemistry. I would like. Okay, there is a question. During this pandemic condition, how would we utilize our time with chemistry? I would like to know: is there any online courses provided for students? This I'm not sure. Maybe I think from St. Joseph's College they are organizing a series of webinars on different topics. Maybe not every day it is not possible for them to engage you, but there will be a lot of informative things going on. So try to attend that, be informative. If there is something you could already start doing from your home, like if you're a master's student or if you're a bachelor student looking for master degrees abroad, what are the procedures, when to start, what are the documents we needed. Maybe IELTS is necessary, so you could start a basic study from home. So I would say use this pandemic condition very effectively. You can do so much of things depending on at which stage you are and what you are looking on. So But I don't have any special recommendation for any online courses. Maybe this you should figure it out by yourself. Just a second. Okay, so I think some of the questions have been answered, but still there is a lot of questions, and it was a great pleasure that so many of you attended, and there is a lot of interesting questions. This is the most important point. So you are not just simply sitting back, you are also thinking about how you could relate it. This was also very nice to hear and see from your questions. As I said, the contacts and the questions will follow soon, and there are any follow-up questions, we could get in touch, and I could support as much as I can. As I said before, it would be impossible to recommend or to find positions or something. So this all you have to do it by yourself. But any other technical things, whether you are feeling confused, can I do that this or something? Maybe in this such cases, I could put my or I could give my inputs, and I wish all of you a very big success in your life. So by choosing chemistry, you will never be a failure. This I promise you, 100%. Only thing is that you have to be a little bit motivated and passionate, and you have to look a little bit deep into it. It's not about studying the way the people who already have their chemistry, how do they do it. So get little bit more feeling for that, and this will all help to get that motivation for you. And with this, I think we could close the section, and yeah, maybe sometimes see you later with another topic or in another time. So have a wonderful evening. Nice to talk to you. Thank you very much. Bye.